Hello.
Hi, Fumi.
So, can you introduce yourself?
Sure. So my name is Asheesh Leroy. I'm a software engineer at Creative Commons in the San Francisco office. That I sort of discovered free software around '99 when a friend introduced me to this system called Linux, and I quickly got to appreciate both the quality and the modifiability of the system. And so then I was paying attention to the free software world for a few years, and then when I heard it about Creative Commons in 2002, it struck me as a very appropriate translation of the ideas of free software into the media space. Right, and I started as an intern in 2006. And I've been involved, I've been involved in the community for a few years before then, actually. There's this organization called Students for Free Culture that was started by two people, Nelson Pawlowski and Luke Smith at Swarthmore College. And the organization promotes ideals like Creative Commons and Electronic Frontier Foundations, privacy, technological liberty, access to information, and the ability to use all of it in a coherent way, I guess. So there's free software principles there also. And but that organization got started because in 2003 this company Diebold makes voting machines, among their many other things they make. And their voting machines, it turns out, are tragically flawed in that you can walk up to them and vote as many times as you want if you walk up with the right card, that sort of thing. And also there's no printed log, so if anything goes wrong, you're just doomed. And so Luke and Nelson came across the memos from within Diebold that explained many of these problems, and they were emails between engineers and support staff and so on, asking, "Hey, I have this broken voting machine. What do I do?" Which serves to the public as these machines actually break in these ways. So they were interested in sharing these memos, and they did, and there was some legal tussle that followed from that, and they, along with an ISP, online policy group, sued Diebold because Diebold was threatening them in the first place. And that lawsuit was handled by the Electronic Frontier Foundation. So that was in 2003. And that was early in my understanding of Creative Commons, and early in Creative Commons' history, I guess, also. And where it put me was in the position, well, what do I do with these memos? So I joined Luke and Nelson and a bunch of other students in sharing the memos on my web space, and eventually the FF asked me to write some written testimony for that case about my experience with these memos. And then, a year later, Luke and Nelson discovered there was interest in these access to knowledge issues outside of just where they were in Pennsylvania. So they created the organization Students for Free Culture. So I've been involved with that since since its existence in 2004, but sort of before its existence also in 2003. And the interest, a lot of the people who come to the Creative Commons internships come from chapters of Students for Free Culture. So Timothy, for example, is at University of Michigan. He's working with me now in live content. He was an intern this summer at CC. And he also has been involved with the Students for Free Culture chapter there. So Timothy brings up actually the link of why I'm in Tokyo in the first place, which is that I'm here because John Wilbanks from Science Commons wanted me to present on one of the flagship projects of Science Commons called the Nero Commons to a Japan-United States collaboration meeting on creating a global information commons for progress in the frontier sciences. And the point of the meeting was to try to expose ways that Japan and the US can collaborate in sharing data with each other and within their own scientific communities, and to focus not only on how to do that, but on the benefits of that. So Science Commons has this, as I said, excellent project called the Nero Commons, which is about taking data from diverse sources, databases that weren't meant to work with each other in the first place, and attaching to them the technologies called the semantic web. And once you've done that, then you can create meaningful queries that go through all the data sources and query them have the computer handle the querying, so you don't have to know. So when you want to find, for example, a list of genes that have some where you know some details about them. The problem right now is that these data about the genes will be stored in different data sources, and you might even want to say, find me all the papers that talk about genes, where those genes in some other database have been associated with this symptom of this disease. So that's a lot of data sources you'll need to query. And the point of the NeuroCommons is to demonstrate how the semantic web technologies let you tie all these data sources together. The link to Tim is that a professor of his was also speaking at the conference, actually, on the sociology of science in particular. He is at the information school at the University of Michigan. So that's why I've been in Tokyo. There's also a lot of data out there for scientists, but there's also a lot of data that's hidden in labs. And the sort of tragic thing about all this data is that it can't talk to each other. It can't talk to the work that its collaborator has been doing with it in the U.S. as part of the Japan-U.S. question. But take, for example, so these data sets that I mentioned that Science Commons has been integrating, they're data sets that are strictly in the public domain. They're created by the U.S. government, groups like the National Institutes of Health, and but they, after a strong push to get the data available and harvested out of the researchers that have been generating it and doing experiments, all you end up with is a web page where you can, for example, download some giant file or enter a query into a form. But what you want in science is to be able to get precise answers to interesting questions. And these databases are domain specific. They're just one field of research. So the benefits that something like NeuroCommons brings is that it can integrate all this data exists. And there's lots of technology for databases. There's SQL, there's the semantic web querying systems. The key problem with SQL, though, is it fails between institutions. You can create the largest database you want in-house, and you can do complicated joins and stored queries and all these things. But if you want to collaborate with someone whose data is not in your business's server rack, then SQL can't help you. So the semantic web technologies can. And that's why we thought it was exciting to tie together all these existing data sets. At the conference, there were some other people talking about different approaches they've taken. So the other nice thing about the semantic web approach, as we've done it, is that it's sort of bottom up. There's been this top-down push to create all this data, and it's been a success in the sense that we have the data. But if you were to have the same kind of top-down push to integrate all the data to make it fit the same standards, it would take twice to 10 times as long. Whereas what we've done is it's sort of very much in the internet philosophy. We've taken what's there, we've adapted it to our needs. But the great thing about the semantic web is we can run servers that will query the NIH data, so that if you create your own semantic web database system using Sparkle, you can add the data that you don't have in-house to your query just by adding a URI that references our data set. So that's the real benefit, is this collaboration between organizations. And the really great approach that we've taken, I think, is that it's bottom up. So we don't have to get permission from NIH. We don't have to do anything that we could do. All we did, anyone could have done. It's just that we thought to do it, and we had the technical expertise to do it. And I think that, so you've seen this, you'll see the same kind of history, I think, with the semantic web technologies that we've seen with the other internet technologies, which is that at some point, there's a whole lot of choices, and some of them are very good, some of them are very widely used, and sometimes it's even the same one that's both. And one of them will win out, and it's usually the one that's best able to cope with distribution and that imposes relatively few limits and makes it fairly easy to work on top of it. And after that happens, then you see a massive growth in technologies that build on top of that platform. So at Science Commons, we think that the semantic web will be the semantic web database technologies and information access technologies will be, they're already standards, but what we look forward to is when they're ubiquitous. And when that happens, people will just, you can imagine if there were multiple email systems before electronic mail was universal. People saying, well, I don't know if I want to deal with the complications of creating my own email server running my own email server, because maybe in 2 or 3 or 5 months, or in 2 or 3 or 5 years, the internet will decide that we'll do something else. And now you install postfix from the free software community, or install some other proprietary mail server. You just deploy it, and you have email. And if you want to innovate in different ways, you can on top of the email system. And you can innovate in the client interface, like with Gmail. Once you consolidate on one of these standards, you create a huge amount of possibility for communication with it. So I mentioned that the point of our work with Neurocommons is to help you answer interesting questions and get precise answers back. So this is one of those interesting questions to some scientists. You might want to find some genes that are involved in transducing signals, because that would probably make them a good drug target. And you want to find those related to pyramidal neurons so that you can help address Alzheimer's disease, in which pyramidal neurons are implicated. So here is this question, and the problem is that the data sources you need to answer this question are numerous. I've put in bold here some of the particularly important data sets. But you can see things like MESH and the Allen Brain Atlas. These are public domain data sets that are maintained by organizations within the United States. There's also the scientific literature, which is some use. But it's not pure data, so it's harder to get information out of it. So what we've done is bring these data sets together. We've tied them together using the semantic web technologies I mentioned. The key one has been Sparkle and OWL, which is an ontology language for describing what the database's contents mean. So this is the way you phrase that question. The interesting thing here is that you can select a gene and a process that it's involved in, and look for you can get the gene information out of this database by invoking this URI, which is just like a URL. You get this identifier from this database that represents a gene, and you get this identifier from this database that represents a pyramidal neuron. You can cross-reference the literature, the scientific literature, because what we're doing is we're taking the journal articles in PubMesh, selecting papers where the gene or gene product mentioned by the article, where pyramidal neurons are involved in the paper. And so this is a question in our methodology, and the answer looks like this. And we asked Alzheimer's disease experts, and these are in fact an appropriate list of genes that are involved in related to Alzheimer's disease. So, and these aren't just slides. This code works, and that's the really exciting thing about Neurocommons. So, I can actually show you that if you click on this link, this very long link that contains that entire query, you will go to a web browser that answers that question.
Ooh.
And so we're working on some more exciting interfaces to this. You can see a sort of basic one here. But that's the key thing, that we came up with a methodology for integrating these databases bottom up. We wrote the ontologies, we put it together, and now we can ask questions that scientists deserve answers to. So, a lot of the same process has happened in large pharmaceutical corporations over the years. But the way they've structured it isn't flexible, so that every 5 years they have these massive pushes to get all their data to fit together. And then after 5 years it's out of date because they have more data sources. Whereas ours is more flexible and can work between organizations just as well as it can within one organization. This, as I mentioned, is a long link, but it's just a link. You can click it and get the answers in a web browser. So you can save that sort of link in a web page, so that you could email that link to a friend, and then, great, you'd all both be able to do the same query. But the nice thing about, even if you don't understand the way that query was structured, and you might want to change it, even if you don't understand it, because you're a scientist, you have more important things to do than understand the workings of the World Wide Web Consortium's latest standard. You want to find an answer to a question. So you might get... So I showed you in this query, there's these bold IDs. So this ID here represents signal transduction from it's an identifier from the database Go. And this represents pyramidal neurons in the database mesh. So if you want to ask the same sort of question with different values filling in the blanks, then you might go to the website of Go, search for ribosomal proteins, grab the ID number, copy it to the clipboard or something, go to mesh, grab the heading for neoplasms, and now you can search for neoplasms, and you can ask the same question, but
just change the parameter.
Right, just change the parameters, exactly. And the model we have in mind for this is something like view source on web pages. One of the big factors, I think, in the growth of the web is how easy it's always been to understand, even if poorly, what other people have been doing, so that you can then retool it for your own use. And the nice thing about view source is it's much more accessible than software source code, and it's all in front of you. There's sometimes things like JavaScript that come from other pages, but by and large, the HTML that you see in your view source window is all you need to reference to change it. So you see some word that you want different, and you replace it, or you see some table element you want a different color, you find the part that says color, you change it, and now you have something that does what you want instead of what the original creator created it for. So you can run this query just as well, and you can bookmark it just as well. And this kind of changing of the query is something that used to take informaticists days or weeks to put together, because the databases had complicated structures, and they weren't user modifiable. The queries weren't user modifiable in this kind of way. You'd go to your librarian or that sort of thing, and you'd ask, please find me this. But when you bring the computer technology so close to the user, then just like with view source on the web, just like with this, you empower the user to change it and make it more useful for his own uses. John Wilbanks is the vice president of Science Commons, which is a branch of Creative Commons that's based in Cambridge, Massachusetts at MIT. And its mission is to make scientists understand the value of sharing information. And the way it does that is through a few very practical applications and and it has some ideas that it tries to explain with demonstrations. So, one thing that it's working on is open access to scientific literature, which is straightforward enough. It's the idea that journal articles should be able to be read by amateurs and by scientists across the world without being charged for that access, but in particular without restrictions placed on that access even other than money. So, like, for example, there's a journal that MIT decided to stop subscribing to because they added digital rights management software to the journal articles they were distributing, so that these are the kind of technologies that make copy paste impossible, and these are the kind of technology that have no place in science. we are also, so that's the open access literature side of Science Commons. We also have a materials transfer side, which is that we want to get scientists to share not only digital information, but physical information, like test tubes with very interesting results in them, or mice that have particularly interesting gene sequences alive in this mouse. Science has always worked better with a culture of sharing, and we're trying to remind scientists of this and make it easier for those who already agree with us to share. And the other side is this technical side, which is what I came to present about, which is the NeuroCommons project. And that's where you could call it enhancing the infrastructure of the World Wide Web to make it the semantic web, and building these smart database systems that can query each other and understand what the other databases contain so that they can continue to use the information to answer your complicated question. So the point of the semantic web, you could say, is to step away from you looking at a web page with a form and have you, instead of entering text into fields, ask a meaningful question and get back meaningful answers from wherever on the web that data might live to answer that question. So those are the three projects of Science Commons, and it's headed up by John Wilbanks in Boston, and it's a side project of Creative Commons and it's part of that organization.
How many people are working on Science Commons?
I think that there are about 5 or 6 full-time employees, and there are some currently part-time technical people also helping. We are creating a licensing interface for the One Laptop Per Child project's laptop, and also integrating metadata selection and showing into the journal, it's called, so that if you get a file from the internet, you can see that it is Creative Commons licensed in the regular place you browse files. The ones I've been testing are PDF files, like books. That's actually been one of the main applications of the laptop because of the excellent screen and the mode it has to go into low power mode, but look as crisp as an ebook reader, or maybe crisper. So books are one that we can embed and then see the metadata in, and another. You should be able to do it with music files or video files as well. There's a sort of center of contact with the laptop called the journal, where the laptop has abandoned the regular save and save as file paradigm, and what it uses instead is it keeps an entry of all the things you've done in this area called the journal. And when you click on that activity, if you click on when it appears yesterday, it'll restore that activity to where it was yesterday. And so on for different times you launched the activity. So you have to think in terms of activities, not in terms of files. And once you do that, the operating system exposes activities on the network. So when you're browsing, you're in the network view to see which of your friends are online, or you're seeing what wireless network points are available. You can also see what activities are floating around, sort of on the screen as if they're in cyberspace. And when you click them, it'll then open the activity on your computer with the state, even if that activity was shared by somebody else. And so the other one I'm working on automatically selecting freely licensed content from repositories like Flickr and archive.org and these large places to build into an automatically generated collection, which we will then filter down further. But the use of this will be, we've created and we're updating this distribution called live content. That's a bootable Linux image on a disk that will also come with these automatically selected content files. So that way we can demonstrate not only the importance of free software, which the disk will be based on, and the ability to modify your software and use all the software, but also show that in combination with the ability to have content you're allowed to license, you're allowed to share, modify, and reuse. And so we'll be shipping these tools, the content side and the software side together. And so I'm working on this selection. What I'm doing right now, first of all, is just using Flickr's interestingness feature to select the most interesting photos that are CC licensed. It's aimed at people who sort of want to get into content uploading and modification and sharing using computers, but don't have a starting point yet. So giving them something to work with, both on the software and the content side. Yeah, we're trying to take advantage. These groups like Flickr are already taking advantage of the data they have on which photos get looked at and what types of photos get looked at and by whom. So we're trying to select some of the most interesting user-generated content based on exactly that goal. So it's I'm the lead technical person. We also have Timothy Vollmer, who's a part-time worker at Creative Commons, who's focusing on getting people, raising awareness of the project, and also assigning me exactly what to do. John Phillips is our community manager, and he's overseeing it. So it's the three of us are really the people working on it.
Mm-hmm.
My background has been technology, and the future I always felt of free culture is not only free software, but things like participatory media, things like blogs that help people communicate with each other, things like networks that don't discriminate based on their use, and other. Basically, as an engineer, as a software engineer, as a technical person, I want to make all the great things that I've perceived about the internet and technology available to everyone, to the extent that they can use them. And so Students for Free Culture shares this ideal, as I've said. And so I have this server in the lab here, and it hosts my personal email, but also more importantly, it also hosts the website and other services for Students for Free Culture. It was particularly... I've been involved with the website of that for a few years, and then there was this massive data loss from the people who were donating us data service in Boston, and I thought, well, I can do better. Having had a lot of experience with free software and with hosting network services, I thought that it would be good if I could donate my services to Students for Free Culture. So I do. And that's the most important thing the server in the lab here runs. And I can show you the website for that, actually. So this is currently a wiki that I began in 2004 for Johns Hopkins, which was my alma mater. But I'll take you to the freeculture.org website now. So this is the current website. The important thing about Students for Free Culture is that it's, again, a bottom-up organization. We don't have consistent sources of funding on a national or international level. But what we are interested in is getting local students to be active on these issues. So the crucial thing to see here is the list of local chapters, which is almost as tall as my screen, which I'm pretty proud to say. And this server in the lab hosts blogs and wikis for many of these chapters now. So for all of the benefits you would think of being this unifying organization of Students for Free Culture, even we suffered this data loss a year ago of our host being careless, I guess. So many of our chapters have experienced the same sorts of issues, or the people that the students that run them graduate and take their web hosting with them. Many of the universities don't provide web hosting suitable for running interesting websites like blogs and wikis, or other participatory media. So we do it, which is to say I do it, actually. My title with this quasi-organization, Students for Free Culture, is web team leader. But really, I put together the server and I make sure it all works, and I make the systems that let us host other chapters' websites easily and well. So my work, I try to do my work well enough that no one needs to remember I'm there, basically. And these local groups need something to build on top of, like software needs physical hardware to work on top of. These student groups need communication media. But once they have it, what they do with it must be their own. And the success that we've seen in the 20 to 30 chapters that we have is from local students being excited and doing what they like to do, which is talk about these issues, raise awareness, contact their libraries, encourage open access, and not what they don't like to do, which is fix servers that are melting. So this website, as I said, is hosted by the lab, and we're hosting other chapters websites also. The University of Florida, for example, is one of our most active chapters, and this is their website, hosted downstairs also. So you can see that they've taken a lot of different approaches. There's on this page, there's an open art exhibition where they involve the community to get together and show each other Creative Commons licensed works. There's also a politics aspect in the middle, which is where they're discussing the Federal Communications Commission's recent suggested submission of a plan to change some rulings. And the students at Florida Free Culture think that, they're interested in the results of this. And the top one is a purely community thing, which is Copy Night. And that's actually in collaboration with another organization that runs these Copy Night events. They're another bottom-up, get people who are interested in participatory media, interested in free software and free culture, to talk with each other and network so that we can be stronger together.